for product development. Before starting off the session, I would like to request Dr. Prashesh Kumar Mohanty sir to kindly introduce our speaker for today. Sir, please.
Thank you, sir. A very warm good morning to all the participants. So welcome to this last and final date of this EDP on design software for product development. We hope you have already enriched with knowledge on many design software in last 4 days. Now I take this opportunity to welcome today's expert, Dr. Subhasri Kundu, for this training program. So let me give a short introduction about Madam. Madam has completed her MTech and PhD from NIT Raulkela in the field of robotics. And currently she is working as an assistant professor in the School of Electrical Engineering, KIT University, Bhubaneswar. She has published articles in many reputed national and international journals, conferences on the field of robotics. She has also expertise on many simulation and design softwares like MATLAB, PLC, LabVIEW, VREF, ROS, and many more. Despite of her busy schedule, she has accepted our invitations and agrees to deliver the lecture on this training program. It's a privilege to Madam with us to give a lecture on this LabVIEW. So with this short introduction, once again I welcome you all to this EDP. Now I am sure we will be enriched by the today's session. Thank you. So now I handed over the session to Madam. Madam, you please can proceed now.
Thank you very much, sir, for this warm welcome. Very good morning to respected professors of NIT Arunachal Pradesh and dear participants. So I think you people have already enriched with different design softwares for product development. So this is one more introduction of the one more software, design software, you can say, that is your LabVIEW, which can be mostly used in the automation industry. We will come to it. Basically, this LabVIEW is what that we have heard about C programming, we have heard about MATLAB programming, right? But thing is that LabVIEW will give us something new. That is what? That graphic representation of a program code. Okay. So we will not write anything here. Okay. So we will do our programming by some graphic interface. Okay. So we will come to it. So definitely this presentation will be covering this introduction, LabVIEW environment, LabVIEW programming concept, and how the software, or we may say that simulation software that will be helpful for our industry purpose or to do some project, how we can do that. So that will be covered in this session. So that introduction for the LabVIEW, that it is an acronym for the Laboratory Virtual Instrument Engineering Workbench. Okay, so basically we are representing instrument virtually. What instruments we are using in case of our engineering branch, that will be representation will be in terms of virtually we will try to represent it. So it's a graphical based programming language. This VI is an basic LabVIEW element, that is your virtual instrument. The programming languages such as C, C++, basic use of functions and subroutines, LabVIEW use the VIA. And this is the product of National Instruments. So that can be downloaded from the website, that is ni.com, right? Download, that is National Instruments. So it is it may be 32-bit or 64-bit. So there is a hardware device too to implement this MATLAB software. And we have this LabVIEW control design and the simulation module, and like math script, RT module. So this thing we have to download when we are downloading it. Okay, there will be several options will be there. So this options should be ticked to install it. And so this LabVIEW will cover different areas, like it will configure, it can do some mathematical operation, we can write some text here. And here is the simulation also, Simulink, that thing we are doing in the MATLAB, like it may be represented in terms of a state chart. Okay, so these are the different platform, desktop platform, that where we can use the, we can install the LabVIEW. And here is the different embedded platform too, so that in the embedded platform also we can implement our LabVIEW. So here is the different hardwares which can be interfaced with the LabVIEW software. So basically, our operation means our objective is to control the hardware element, right? So whenever we are going to some industry or we want to do some project, right? So simulation software always will help us to drive an hardware device or to interact with the hardware device, which command we want to give, right? Some control command we want to give. So these are the different hardwares through with which the LabVIEW can do the interface. So at our user end, we can do the programming in the LabVIEW, and at the output level, we can receive the output in the hardwares. This Arduino system, this camera, like stereo, that is the NI National Instrument product, Zigbee, this water tank level controller. So all these things we can use to interface this LabVIEW software. So what is the benefit here? Basically, that even people with limited coding experience, so basically those who are non-programmer, so they will have a good platform for this LabVIEW. Because in case of LabVIEW, we need the concept, no need language. Okay, it doesn't require any language. It only requires the graphic representation. So that coding experience can write the programs. They can deploy the solutions in reduced time interval. It also includes an interface to .NET framework assembly. This code can be reused, and this is platform independent. It doesn't depend upon the operating system. Okay, so it can be installed in any operating system. So easy to code programs, multiple tasks performed in parallelly by multi-threading, means we can run the LabVIEW programs simultaneously. We can run 3, 4 or multiple LabVIEW programs together, okay, parallelly. So these are the different benefits of it. So the basic application area of LabVIEW, we can say that is more machine monitoring and control. The LabVIEW real-time module will help in preparing powerful machine monitoring and control applications. Research and analysis. Scientists and researchers are mostly use it in the biomedical, aerospace, energy industries. So control design, real world data can be compared with the theoretical data. Okay, so like these are the different applications of the LabVIEW. So in case of control design, that is the main aspect of normally we people are doing that. The people with the background of mechanical engineering and the electrical engineering. Anybody is from electrical engineering here? Any student? No, right? Anyone from computer science?
No, ma'am. Basically, we are having from civil and mechanical.
Mechanical. Okay, okay. Civil and mechanical. Okay. So civil people are having a good opportunity for the LabVIEW also. This is an design software, so they can do their own topic on to design here. So this LabVIEW real-time module will help in powerful machine monitoring and the control applications, right? So these are the different areas where we can implement the LabVIEW. We can use the LabVIEW to control it, to do the analysis, to get the output, to control some hardware module. So basically that normally we are thinking that people normally when you are entering to the engineering, like, or you are entering to the polytechnic, so they are having a little bit knowledge of C, like we are starting with the C, right? So in case of C and lab, you have a analogy between them, right? So like here we are using the term in case of C, in case of LabVIEW, we are using the term VI. Here C, in case of C, we are using the term function. Okay, so here it is the command, and here it is the drag and drop units. Like we will take the unit, we will take the graphic representation, and we will just drag and drop it. Instead of that, in case of C, we have to write the command, right? Similar way, we have command window, we have here block diagram. We are representing our program in terms of a block diagram. Okay, all the programs are represented in terms of block diagram. So similar way, user interface in case of C means user side, that we are having front panel for VI, for our LabVIEW software. Okay, so file extension will be saved as a .bi, here it is .c, right? So here it is math script, here it is math studio, right? Like that, the analogy is there. Okay, so basically we want to say that whatever we are doing in the C programming, same thing we can perform in the LabVIEW also, with some less effort and less complicacy. Okay, so next we will come to the LabVIEW environment. Okay, so because we got the introduction of the LabVIEW, and after that we will start with the LabVIEW environment. So what are the environment objectives? Like we will have three panels, basically three part of the LabVIEW, right, where we can write our programs. So that is our front panel, block diagram, icon or connector, and all will be work together. Okay, so this we will come to this features, that what is this front panel, what is this block diagram, and within the block diagram we will have several icons in the front panel also. So learn the difference between the control and the indicator. What is this control and indicator? Control means you want to give some input. Controls is representing the input, and indicators is your output. Okay, so always when we are using the term that control, we want to give some input, and indicator means it will be representing our output and be able to recognize their block diagram terminals. So definitely each block will have some terminal. Learn about the capabilities and the use of the toolbar, tool palettes, and the control palette, function palette, sub palette. So all this we will come to the means their features, we will come to it. So basic the three part is there, like front panel, block diagram, and the connected pane. So what is this for front panel? Front panel is definitely interaction with the user, and block diagram will contain what? It will contain the main code. That code we are not writing, we are drawing. How we are drawing? We are doing some drag and drop operation. Drag and drop operation, and there this what we will drag and drop? Some icons, some graphic icons, which will represent something, some component, it will be represented by that icon. So that block diagrams will be connected together. There should be some connecting mechanism, right? So in the front panel, we can have a look of the front panel. So here is the look of the front panel. So this one is will have some view, project, like operate, tools, window, right? So from the help we can see the different, if we need some help that we couldn't able to understand. So in that case, we can go to this help, Control H we can place, and we can have some query. And in case of this front panel, we are having one more button, like it is called run. See that this button is your run, and here it is, that is one symbol is there that represents is run continuously. Okay, so and if there are some errors, it will come here. We can do the stop also. Okay, so that is the front panel. It is the user interface, right? So this right click on the palettes pop-up, connector pane, terminal connector is there, is a part of the front panel, and the caption and level are both in the front panel properties. Traditional debugging features are not available for the front panel, means we cannot debug the program here, because this is not the program end. This will not give us that program. It will show us that what is our front end, what is at the user side. Okay, so here we can not see the logic. Here we can only see what are the inputs, what are the outputs. Okay, like that. If we are giving some condition, so that also will replicate here. We are putting some condition here, because condition is also one input for us, right? So front panel will contain only input and output. So definitely it is a combination of controls and indicators primarily. So what is this control and indicator? That we can see, have a look on it. That is the representation of a control. See that in the control we are having two arrows, right? Here two arrows which we can increase or decrease. But in the output we doesn't have any arrows, right? Because we don't want to, we cannot control the output. output will depend upon whom? Definitely on the control input as well as the logic of the circuit, right? Logic of the block diagram. Okay, so we cannot, there will be no indicators, means there will be no increase or decrease button for the indicator, because indicator will receive the some command, and according to that it will indicate us some value, and this control input will give us some, we can control it by changing the value. It is our end, we can import it. Okay, so that is your inputs, and here it is outputs, right? Okay, so that how we can manipulate it, that if we take the right click on, we will have a look on how we are doing it, because we will have a lab view environment, and after that, before going to the practical view, we are discussing this different features so that we can easily do it in the practical section. So this right click on an indicator will try to change the control or change the format or precision. Like if we drag one control input here from the function palette, so from the control palette, and after that, what we will do in the front panel, what we will do, we will try to change its value, right? We will try to change its value. So to change the control, we will right click on it, and we can change its control or format or precision, or there are many options will be there to change its name, like that. Okay, so right click on a control to change to indicator, to change to mechanical action, whether to latch open or closed, like that. So there are many commands we can give. Okay, so there are two parts. One is your indicator. In case of indicator, we can change the control. In case of control or the input, we can change it to indicator also, and we can change its mechanical action. Okay, so how it will be mechanically operated. So next we will come to the block diagram. After front panel will contain what? Front panel will contain two things. One is indicator, another is the control. So how we will get this thing? We will press right click button on the, front panel, and after that we will get this two part. Here in this feature, we will do the right click, and after that we will get two part. One is the input, that is the control input, and the indicator. Okay, so and after this control palette is the front panel is ready, and after that we will come to this block diagram. So what is this block diagram? Block diagram level is the block diagram property. Right click on the function planet will pop up. So see that in case of front panel, if we do the right click, we will have a palette that called control palette. Okay, so from the control palette, we will take our input and output. Okay, after that, we will come to this function palette. This function palette is what? It is a component of the block diagram. Okay, in the block diagram window, there will be two windows always for the lab view. One is the front panel, another is the block diagram. Okay, so in case of block diagram, we will, if we do the right click on the function palette, we will come to the function palette. So here we are having some debugging feature. Okay, so that we can debug the program here because we are designing the program here. So this is a feature of the block diagram. This feature will be, which will contain the code or the graphical representation of the code that we can see. So how this block diagram window will look like block diagram window will hold the graphical source code, right? And it is actually executable code. If you construct the block diagram by wiring together the objects that perform the specific functions, the various components of a block diagram are like terminal, nodes, wires. Okay, so these are the different components of a block diagram, just like a circuit. Okay, so these are the different components. So there is a, when you place a control in the indicator, like here we have placed one control or indicator here. how it will look like in the block diagram. See that when we have put a control input in the front panel, the same will be replicated here in the block diagram panel. Okay, the lab view will automatically create a corresponding control or indicator terminal on the block diagram. Okay, so that will be denoted by this block diagram. In the block diagram, it will be replicated. Okay, it will do the automatically, it will do the by lab view. Okay, so the control terminals have the thick border and the indicator will have the thin border. That is the difference between the indicator and the control input for block diagram. In case of block diagram, we will have this type of that. See that here it is digital control, here it is digital indicator. That is in our block diagram side. So we have decided our input and output. After that, we will put logic between them. That is the program between them, right? That is will be done in case of our block diagram window, right? So indicator will have some thin borders, right? So here what will have the component of the block diagrams are what? That is the nodes, that is the program execution elements, okay? Terminals or ports through which the data will be passing through the block diagram, between the block diagram and the front panel and the between the nodes of the block diagram. Okay, so and definitely the wires, the data paths between the terminals. Okay, so these three things are very much important for the block diagram. Block diagram is nodes means what node or what graphic icon we are taking from the function palette. So block diagram window will contain the function palette if we do the right click there, and from that function panel we will select these nodes, and here there will be some terminals associated with the nodes through which the data will be passing between the block diagram and the front panel and between the nodes of the block diagram. Nodes of the block diagram is what are the components of the blocks or the blocks, we may say the blocks. So, and the wires, definitely the data paths between the terminals. So, this connector pane, which means the passing the data to other VI. So, if we want to transmit the data from one window, one VI window, that means from one program to another program, that we will represent by this connector pane. The connector pane terminals display the color of the data. Okay, so this is the view of the connector pane, right? If we want to represent it, if we want to do this, if we want to connect one more lab view program here, so we will connect it here. That is the view of the connector pin, that this lab view program is connected with another one, another code. Okay, so there is one more option is there, like if we need some help, this is the enabled by selecting this item from the help pull down menu. If the cursor is placed over the particular button, a small box will pop up with its description. It is also activated from the help pull down menu by selecting the show help, like control H. If we place the control H, so here we can have this view like contest help. So basically lab view is doing some data acquisition. Okay, so when you place the express VI on this block diagram, the DAQ assistant, that is your data acquisition assistant, launches to create a new task. Okay, so after we will create a new task, you can double click on the DAQ assistant express VI to edit that task. Okay, so for continuous measurement or generation, place a while loop around the DAQ assistant express VI. So basically it is giving us that if we, this one is an example of how in the help will give us some data, some description. Okay, so we want to have some knowledge about the DAQ assistant. Okay, so what is this data acquisition that we have to know, right? So the traditional experiments will have some signals from the sensors that are sent to the analog or digital meters and read by the experimenter by recorded by hand In automated data acquisition method, the sensors are transmitting voltage or current signal directly to a computer via a data acquisition board. Okay, so the software such as LabVIEW will control the acquisition and processing of such data. Okay, so basically what this LabVIEW is doing, that in case of traditional experiment, we have signals at is two analog or digital meter, right? But thing is that it cannot be recorded. Data cannot be recorded. It can be recorded manually. It cannot be done in a automatic way, right? So this automated data acquisition system have some sensors which will transmit the voltage or current signal directly to computer via an data acquisition board. But this data has to be stored, right? Has to be processed, has to be used somewhere, right? In some program to get some output, right? Desired output. So that thing has been done by this LabVIEW. The LabVIEW have the benefits of automated system is what? That it can improve the accuracy of recording, it can increase the frequency with which measurements can be taken, and potential to automate the pre and post processing and built-in quality control. Okay, so these are the different benefits that we can get if we use the LabVIEW in an automated system. Okay, so it will improve the accuracy of recording, definitely, the increased frequency with which the measurements can be taken, the potential to automate pre and post processing and built-in quality control, right? So this LabVIEW programming concept will have some data flow programming. That process to determine the execution of program is called the arbitrary interleaving. And during the compilation, the VI compiler will construct an where table. Okay, so the LabVIEW functions are polymorphic, and LabVIEW is not an interpreted language. It is compiled behind the scenes by the LabVIEW execution engine, right? So this, in the programming concept, what we can say that it is following the data flow programming. That means it's a continuous flow of data, that maybe input is having some continuous or automatic data from the sensor. It has the process to determine the execution of the program, that is called arbitrary interleaving. And during the compilation, the VI compiler will be constructing a where table. Basically, it is doing what? That when we are compiling the program, it is representing an table which is connected, and these functions are polymorphic, and it will interpret the language, and it will compile behind the scene that we cannot see, and in the execution engine it will be compiled, right? So these are the basic LabVIEW programming concept. And LabVIEW will construct a wire table for the VI. The wire table have the identifies the elements in the block diagram, and they have inputs needed for that element to run. So definitely we will have this inputs at the front panel, right? So this block diagram will have some elements, and LabVIEW program is executed by pressing an arrow or the run button located at the palette along the top of the window, that we have seen already. The front panel will have some run button. With that button press, we will run the program. So definitely that we have already discussed that it will have, the LabVIEW will have three palettes: the function palette, control palette, and the tools palette. Okay, so this function palette will do what? Function palette will do what? It is that I have told you that function palette will be a part of a block diagram. If we right click on the block diagram window, we will have this function palette. If we right click on the front panel, we will have the control palette. Okay, and there is one more option is there, that is our tool palette. Okay, so how this control palette will look like? See that here it is the view of a control palette, that it will insert a digital control, digital indicator or the control. See that here it is, the option is there, right? So insert a Boolean control. So this option is for the Boolean control. So there are so many options are there how we can represent our control input. Like here we can represent some waveform also as an input, right? So there are so many options are there. Normally for normal project like the project in the we are used to do in case of BTech level, or we can go for this simple digital control. Here we will have some numeric value, means that representation of 1, 2, 3 in terms of different way, and we may have some Boolean control, that means 0 or 1, right? So it is a button switch, either on or off, like that. So invoke the control panel by clicking the view control panel palette or by right clicking on the front panel. The controls are grouped into categories in a tree. The sub palettes have a lock in the top left corner to keep the window visible while you are working with the controls. So that thing we will see when we will do the program. Okay. So next we will come to the function palette. Function palette is coming where? Function palette is coming in the block diagram window, right? So in the block diagram window, see that what are the functions we are doing. Basically, we got the input and output in case of our front panel, and in case of block diagram window we are performing the operation, right? Performing the doing the code basically. So definitely we need some functions, right? So here we can see that here it is the one block is there, that is called the structure. So this structure will contain the for loop, while loop, different switch case statements. This thing we can create from here, right? If we want to do some numeric operation, so then this numeric operation is also here, like it may be added, it may be divided, it may be multiplied, right? There may be some division, or it may be some comparator if we want to do some comparison, right? Here also we can do it, right? We can go for if else option also, okay, if else condition also. Like here it is the timing or dialogue, like we want to set some timing, we want to give some delay in the circuit, right? So that thing also we can do it from here, right? We will see these options, how it will be used. Okay, so this signal analysis is also there, like different signals like sine wave, cos wave, like this different signals are also there. Here is the data acquisition module also. Okay, so these are the various mathematical operation or different functions that we can perform from this function palette. So basically we want to put the logic between this input and output. Okay, that will be the work for the function palette. Okay, so this function palette, definitely right click on the block diagram and the functions are grouped into different categories, right? So one more palette is there, that is our tools palette. Okay, so to select a feature or to edit or move, or we can do some add of edit text, right? So wires features together to control the flow of data, probe data, right? So that these are the different data that we can control from this tool palette. Okay. So this, what are the different tools? Basically, that one is automatic tool selection, operating value, positioning, leveling, varying. So these are the different tools that we want to do with the functions basically, right? Because we have selected some function, but these functions should be properly connected, properly placed between the input and output to give the complete logic circuit, right? To keep the complete code. So for that purpose, we are using these tools, right? So that is the how the there is one way, that is automatic tools will be selected, right? What is the operating value that we can say? We can position it, we can change its position, we can change its level, we can do the varying and different shortcut menus, scrolling, breakpoint, probe, get color. We can do some color also in the functions. We can do so change the color. Like if the switch is on, it will be red. If the switch is off, it will be green, like that, or just reverse. Okay. So there are different data types that also we can use in case of our functions. Okay. So what is this data type? Like this is a block which can be used in case of function. like numeric data type, string, dynamic data type. Numeric data type means we are using only 1, 2, 3 like that. String means we can use go for A, B, C, D, right? So we can write something there by some using some value, using some name, right? So dynamic data type, Boolean, ring, waveform, variant, timestamp. So these are the different data types that we can use for the different functions, right? The functions what we will select, right? So we can have a look on these functions, right? Because we are using this data types is an component of the function. Different functions we can use, and these data types will be the features of the functions. So next we will have some structure. Structure means in the function we have seen that there are one block is there, that is structure, that will contain different loops, different conditions, that while loop. It will execute at least once when the condition is to execute the conditional terminal. That means there will be some condition. If the condition is satisfied, the loop will get executed, right? So there we can give some condition there. Their option is there, and for loop is also there. Option is there. Like if we want to continue the process, if we want to run the system for a number of iterations. So in that case, we can go for this for loop option. We have to put there the number of iterations, like from the I0 to n, right? If else there one condition is also there, that we will also use. We will do some, we will see some video actually. So that will do the LabVIEW programming with some real-time control system, right? LabVIEW will be implemented in some real-time control. So there we can see that how this loop structure will be used. Okay, so we can have a view of the for loop. The for loop structure is like that. Here it is, we can see there is a n and I. So that is a count terminal. Okay, count terminal, and the I is representing your iteration count, right? So that is a representation of the for loop for the LabVIEW, like that. So here we can see that we are not writing any program, right? We are only designing a block, right? We are taking one block, we are represented graphically. And here it is the while loop feature. So see that what we can see, that is the iteration count is there, I. So that may be your one condition, right? And here is the stop button is there. Test for the stop condition. By default, it is stop if true. Okay, so if the condition is true, then it will become stop by default, right? So there are two do while loop. Basically, in case of while, we will have a condition. If the condition is satisfied, then it will be stopped, right? So that is an iteration count. That is our condition. And here it is the figure. That is a figure or block that we will drag and drop. That is a for if else, right? If this value is 1 and t is executed, if gets the value 0, f will get executed. Okay, like that. Okay, so t means there will be one option like true or false. Okay, so what is the value? Based upon that, there will be two options will be there, that will be either t or f will get executed, true or false, like that. So here is a feature of the switch case, right? So there are multiple cases are there. Conditional terminal. Okay, so here we may have some multiple cases, right? So this is with the case number, we will have one condition. So depending upon the case number, we can have different conditions, right? So see that what are the sub palettes? Sub palettes means within the function palette, as we have seen, there is a structure, there is an arithmetic operation, right? See that here it is the arithmetic operation, right? And here it is pause, addition, here it is multiplication, here it is division, like that. And in the control section, we are having, see that in the numeric control, we will have this type of feature. See that there may be some normal numeric indicator, right? Okay, so there may be some decimal option is there. There may be some like a tank, like a thermometer, Okay, like a clock, like a here it is a linear indicator. Sorry, that is an vertical indicator, right? So there are different options are there that we can choose according to our application. Okay, so these are the sub palettes, and here it is the toolbar. Toolbar is what? Where we will run the program. If we are having any error, it will show us here. This one is run continuously, right? Here it will be run continuously, and if we want to do the stop, here it is the stop button is also there, right? So this is the toolbar, right? Here it is run, continuous run is here, and here it is the stop button, and here it is the pause button. Okay, so font ring, that is the font ring means what we are representing here. It is in the font panel. What will be the font size of the blocks, right? In the front panel, we are using that one is your indicator, that is the control input. Another is the indicator, that is the output, right? So what will be their font size? Would you represent it? Okay, like alignment ring, distribution ring. Okay, so there are so many recorder objects. If we want to record the output like that. So here it is the debugging features. So this is very much important because when we are doing any program, so there must be some debugs, right? Okay. Okay. So what we will do now, we will have some view of real time that LabVIEW application for some real project. Okay. So after that, we will have some example like this thing we will do it in the LabVIEW, that a simple programming, like we want to do the Celsius to Fahrenheit conversion, right? We know this equation, right? So if we put the Fahrenheit, if we have the Celsius degree, we can, if we put the in this equation, we can easily calculate the what is the Fahrenheit, what will be in Fahrenheit, right? So for that purpose, what we will do, I'm just showing you here in the PPT mode, but we will do it in the practical mode also. So see that carefully. In the front panel, what we have chosen, that this one is a control, and this one is an indicator. Indicator is your output. So that's why indicator has been termed as TF. And this control, that is the input, has been termed as TC, that is in temperature in centigrade, right? So here it is the diagram, and after creating this, here we will have this two only. This one is your output and this one is the input, right? So input is multiplied with 9 by 5. Input is multiplied with 9 by 5. So what we will do? We will choose simple from the function palette. We will choose simple arithmetic operation, that is your multiplier. Okay. So the multiplier, one terminal will be connected with the input and another terminal will be connected with a 9 by 5, right? How we will choose this 9 and 5? These are terms as constant. We are using some constant value. So from the function palette, we will choose some of this constant value. Okay. So with this constant, we will do the operation, that is your division, right? After that, it will get multiplied, and after that, addition with a constant again, and directly we will have some TF. So if you could install the MATLAB program, sorry, that LabVIEW program, so in that case, we can easily implement this type of small arithmetic programs, right? It is a very easy one. So that mathematical operation. So we can see it from here, like this convert Fahrenheit to Celsius to Fahrenheit, right? So see that here is an portion is there that is called the how to fix this error and bugs, right? So basically when we are doing the program, so at that time definitely we need this much very, right? We need this one. So see that this symbol is giving us that double click on the error message and LabVIEW will show the what is the error, right? So it is just beside the continuous run button. Okay, so it is just beside the continuous run button. It will come in the toolbar, right? It will come in the toolbar, this error message, this error message will come. The LabVIEW will show us what the error is, and see that if we have some like this type of symbols, so that is representation of broken wire. If the connection is not okay, see that here it is. If we want to add, if we are connecting this output that is your indicator as an input to this arithmetic operation, that is your addition. So that is not possible, right? So they see that here we have declared it as a control input, and after that it is placed at the output terminal. So that cannot be connected. If we are connecting this is a wrong, right? So for that purpose, if we are showing this type of error, so at that time we will remove all the connection. So how we will remove? We will do the control plus B in order to remove all the broken wires. Okay, so like that we can do the programs. Okay, so here it is the control H. So with that we can have some detailed help, like how we can create the random number. So here it is the random number, how we will create, and what is the feature of the random number, means how it is look like, right? So this thing we can see by the control H, right? So one more example with the while loop. Okay, suppose we want to control the level, right? So that is that a voltage signal from 0 to 5 from a DAQ, that is the data acquisition device, needs to be converted to the equivalent level of the water tank, that is 0 to 20 centimeter. Basically, we want to map this 0 to 5 volt, 0 to 5 volt to this water tank level, that is 0 to 20 centimeter, right? So what we are doing, that 0 to 5, and here it is 0 to 20 centimeter. So definitely 5, if we do the multiplication with 4, it will be directly converted to the 20, right? So this conversion we can do it. See that here we have taken one linear indicator, that is vertical indicator, right? So vertical indicator we have taken. We can set the limit. We can set the limit from 0 to 5, and we can level it. Okay, this thing we can do it in the front panel itself. Okay, so and if we right click on this block, on this input, so in that case we can change its value, change its range, like 0 to 5. Okay, so 0 to 5 we can change it, and here also we can select a tank. So in this tank we can set the limit, we can set its unit, right? So this thing we can do it in the front panel itself. And in case of your while loop, in case of your block diagram, in the block diagram, these two will be automatically created, this volt and this semi. Okay, what we have to do, we have to do this operation here, right? So in this block diagram, we can use this multiplication with 4, and it will be wired, right? And here it will be connected with the centimeter. And definitely we want to put this thing within a while loop. Okay, so this block diagram, find the while loop in the function palette and place it on the block diagram. Okay, so here it is one note is there, that is if we want to do something with an object means we want to do some changes in the block diagram on that function. Okay, so what we will do, we will do a right click on it, and after that we will get all the features of it, its range, its property, how it will look like, right? What should be its color, right? How we can level it, right? Everything will be there. So here we have seen that is one in the function palette, one block is there that is called time, right? So here we can add some delay, right? So if we, what is that delay? That if we change the input, there will be a delay of 100 millisecond. It is in millisecond, that wait time has given us 100 millisecond. So if we right click on this wait icon, we can get one change in the, we can edit this value, right? We can edit this value, we can change it 100,000 or anything. Okay, and we can put this delay. If we do the delay, put this delay here, if we do a change in case of our input So in that case, there will be a change in the output too. Okay, so that will be delayed. In the output, what change we are receiving, it will be delayed. Like here, it is the if the position is your uh, 2 volt. Okay, so it should come here 2 into 4, that is 8 volt should come here, right? So 8 volt will come here. If we change the from the 2 to 3 volt, 2 to 3 volt, if we do the change here, so in that case, it will take some time to make it 3 into 4, that is 12. To make it 12, it will take some time. Okay. So that delay we are giving in the system by putting this while loop. Okay. So here it is the stop button we have selected, right? So we can see this thing. Okay. So in a similar way that if we want to control the temperature, this thing we will see in the video, that if we want to control the temperature of any room or anywhere, right? So in that case, we can do this control thing by using some while loop. Okay, so let me show you some interesting videos so that you can have a look that how this uh, okay, we can have an industry look too. So I think it is visible. Uh, let me explain first that what it is doing basically, that in this machine, they are doing what? They are preparing some resistors. You know the resistor that is with some color code, right? So basically they are making some resistors and they are cutting according to their particular resistance. One particular resistance is set there and the whole system is operated through the lab view. We can have a look on it. See that it is rotating at a particular angle, that wheel, right? And it is cutting and everything has been operated through the lab view. Is it visible?
Yes, ma'am. Yes, ma'am. Visible.
Okay. So these are the lab view panels that they are using. See that this is the rheostats, resistors, that it is the product. Okay. So we can watch one more interesting video for the temperature control that I have told you.
Ayaka shoulders her family's duty to cherish
Just
the
a moment.
aspirations of ordinary people. But she
Okay, so this one is doing basically temperature control. What they are doing, as I have told you that this is two panels are there, like front panel and the block diagram. So at the front panel, they are taking the first they are taking one LED. Okay. So this size can be increased like that. So here is one button. So see that here is the, and the block diagram what the feature is coming. So if we place the OK, then the it will glow. So mechanically it can be operated. So here is the structure. We want to put it here in a while loop. One stop button is there. So here we can write it here like test button. So here we can do the changes in the color also with the Boolean properties. As per our requirement. This is our front panel. Stop button is there, and in the numeric control, yes, we are having this control express. Like here we are having the one variable indicator, slide indicator. We can change its shape and size according to our requirement. Here it is the indication of the temperature. Like we want to control the temperature, right? So the temperature we have to give some limit to it, right? So that is this thing is the in the front panel that I have told you that I have shown that toolbar of the front panel. So we can move it here and there. So on the right click, it will come. This is your control. So this one scale we want to change. Suppose we want to change from -20 to 60. Okay, so the temperature will be is in the range. So this is your temperature. Now what we want to do, we want to this is the loop iteration number, right? And we want to put some comparison. Okay, that is comparison is your one is greater than equal to. Okay, greater than equal to, with that we want to give some and less than equal to, right? Upper limit and the lower limit, right? So we will set some temperature limit here. So it will have two terminals definitely, right? So this one terminal will create some constant value. Constant value means we want to give the limit, definitely. Right, that is the constant value, we can give it. And another one will be the input from the temperature. Right, temperature sensor. We may say it as a temperature sensor. Okay, so we can change the position of the wire like that. Here it is one more lower limit. Suppose we want to give the here it is maximum, here it is minimum. So by clicking on it, we can change its name also. So from the temperature will be one more input for this operation, like less than equal to. Okay, so it will compare with the minimum temperature level. Suppose this minimum and maximum temperature level, this thing we can put outside of the while loop. So this type of broken wire we will come if we do not connect them. Okay. So next we will go for the again comparison, that is our not equal to. So the output from the maximum temperature comparison, and next is the input temperature comparison. So programming and the boolean, we will do a OR operation here. That is from the test button, that is our input button. We did that one OR operation here. We will connect it here like that, this wires, and this wire can be shifted by clicking on it and just dragging, and it will jump to the LED. Directly go with the LED. So this much is for our block diagram. Here we can directly run the program, right? So here it is the minimum and maximum value. Suppose here it is 0 minimum and maximum is 30. Okay, so from 0 to 30 it will be operated, right? If it is beyond 30 it will be red. If it is beyond 0 it will be red, right? So the temperature range has been decided as 0 to 30, right? So there is one more one that is called if else. Okay, so this block I have told you, that is if else. So there we may add some string constant. String constant is what we may show some message, right? We may show some message. So that string we may show here. And on the terminal, by clicking on the terminal, we can create this constant or any numeric value. So this thing can be shifted. This become clumsy. So there we can write like high danger. Sorry, it is not high danger. and we may replica the same thing, right? With the increase of the temperature, we can the same temperature output, we can do one terminal for the e-fills, and it will show the display the message. Basically, it will display the message. See there, it is concatenate, and here we will display the message. Either it may be high danger or low danger. Okay, if we run that, if we see that here it is in the string, it will come in that either whether it is high danger or low danger, right? That. Okay. So this is the message is coming for us. So this is one more structure that is called a case structure. That is a flat case structure. Okay, so here this thing we can this thing we can skip because we will concentrate on the this temperature control only. So basically in that temperature control, what we are doing in this temperature control, we can see that here we are using this two comparators, right? One is your less than equal to or greater than equal to with some minimum or maximum value. Okay, and after that this output will be coming. Yes, this input and maximum value, this can be outside the while loop, right? And after that it will be okay, just a moment, just give me 2 minutes. There may be some switch power off at my side. Just give me 2 minutes, okay?
Suji sir.
Yes, sir.
Sorry for the inconvenience that it was a power off at my side, so I got disconnected.
Excuse me, ma'am.
Yes, yes, please.
Ma'am, actually, our next section is going to start from 11:15. So
Okay.
if you finish within 5 minutes, it will
Yeah,
be
yeah, definitely. We have to end within 5 minutes. So,
okay, ma'am. Okay, ma'am. Thank you.
uh, so already we have seen that one small project that what we can do with this temperature control or like this. So yes, we have shown it. So this type of small programs the BTech students or the participants can try, and they can go for the different another program also, that we can have a look on it. Small look, just within 2 minutes we will complete. So there is one LabVIEW program for that we can see. If we click on the LabVIEW, that these two windows will come. Okay, so here is one small program for the traffic light control, right? So this type of small no, yes, this one is for the, yes, thermometer temperature. Okay, temperature measurement. Okay, so this type of small problems we can do, and okay. So there are some different features also, like we may go for like waveform, we may go for a little bit chart pattern. Like if we want to represent it in waveform, we can represent it in waveform graph also. Okay, so like that we can represent. There are certain difference between the chart and graphs, right? So there, this thing we can this have the features also. Okay. So I think time is a little bit short. Otherwise, we should do some hands-on the small programs. So it would be great benefit for the participants. I hope in near future, if it is possible, then we can go for some participation, means hands-on participation. So I would like to thank all of you for your kind patience to listen this session. And if you have any queries, just we can discuss. Any participant.
Yeah, thank you, ma'am. Thank you so much for such a wonderful session. Any participants, anyone having any queries may ask. Mohanty, sir?
Okay, sir, it is fine, sir.
Okay. Okay. Thank you once again, ma'am. On behalf of the coordinators and IIT Arunachal Pradesh, I once again thank you, ma'am, for such a wonderful session on a LabVIEW in automation. And thanks for taking out your valuable time and sharing such information with us.
Thank you, sir. Thank you very much for your. I can participate. That is my honor. Thank you.
Thank you, ma'am. Okay, so with this, we come to the end of the first session. We will be starting shortly with the second and the last session of this FDP. On that will be taken by Mr. Dhrubajyoti Teran from TRTC Guwahati on SolidWorks. So I request all of you to be there, and we will start shortly. After the last session, it will be followed by the validity session from 1, and we are expecting our director sir to join us in the validity session. And I request the participants to kindly share their feedback in the validity session. Apart from that, we will also be sharing few links for the feedback of this EDP program. So request all of you to kindly please attend the last session and the validity session. Thank you.